Okay, with this, we get to this content that I think might be needed. So hopefully I got through this entire piece in class, but if not, this is the second example problem for day 2. We're adding acceleration. So we are working with 2 tractors, or boots with wheels, because that's what I can draw, playing a game of chicken. They are 10 meters apart at the beginning, so this is what my problem is saying. So the distance between the two is 10 meters. That is still on the board. 10 meters apart for a game of chicken. Tractor 1, we'll call this guy tractor number 1, is accelerating at, so acceleration at 1.5 meters per second squared. We're assuming velocity at the start for all of them is 0, and it is going to velocity maximum of 2.5 meters per second. Perfect. And then I have tractor 2, which we're still going to say, we're going to call all the 2's, we're going to put stars in front of them just to keep track of them. Initial velocity of tractor 2, it's tractor 2, so I'm just going to put a star so that I don't have to worry about a bunch of subscripts, is going to be equal to 0 still. It is accelerating slower, so it is accelerating at 1 meter per second squared. But it will make it all the way to a maximum velocity of 3.5 meters per second. If neither driver chickens out, when and where, relative to initial position of tractor 1, will they collide? So my knowns, do I have space for this? I might have to erase my initial stuff for this problem. My known values, velocity at 0, I should just, of tractor 1 is 0. Acceleration of tractor 1, I'm going to double up. I'm going to have the star and the 1, which is the better way to put it, is 1.5 meters per second squared. Velocity max of tractor 1 is going to be equal to 2.5 meters per second. Velocity 0 of tractor 2, we will add stars, is 0. Just makes it stick out a little bit more. If I had more than one color of pen that was still working, I would use that. Acceleration of tractor 2 is going to be, gotta keep the star thing going, 1 meter per second squared. And my maximum velocity of tractor 2 is 3.5 meters per second. So that is what I know. And what I'm asked for is I am asked when and where they will collide. So I need my time of my collision and my position in comparison to tractor 1 at the time of the collision. Those are the two pieces that I want. Now, I cannot just use my relative velocity trick like we did on day one because the velocities are changing, relative velocity is changing. So what I'm going to do is I am just going to start by figuring out how long it takes each of these tractors to reach maximum velocity. So in order to do that, my equation, got to figure out how to get rid of that white box. My equation, velocity final, is going to be equal to velocity initial plus acceleration times time. And I said I was trying to figure out the time that it took to get to maximum velocity. So let's also do one more thing here that I missed. This is the positive x direction, which means that everything going on here is negative. Boom, boom, because these guys are moving the opposite direction. My tractor here is going in the negative direction. Sorry about that, I missed it. Velocity final. Velocity final is my maximum velocity. So I'm getting up to 2.5 meters per second. My velocity initial, I start from rest, I'm not moving, plus acceleration is 1.5 meters per second squared times the time to get to maximum velocity. This is time at collision. So that is not going to be the same as this time, but we still need to find this time along the way to solve the problem. So dividing 2.5 by 1.5 will get me a, we'll call this, I gotta add my star, T max 1. So this is the time that it takes to get the first tractor to the maximum position, is going to be 2.5 divided by 1.5, which is 1 2/3 or 1.6 repeated seconds. Doing the same thing for my second tractor, I've got velocity final of negative 3.5 meters per second is going to be equal to 0, because I'm not moving to start, plus my negative 1 meters per second squared times my time. Negative 3.5 divided by negative 1 is just going to be 3.5. So I've got now my t to my max velocity of 2, remembering the star, is going to be equal to 3.5 seconds. Okay, now the hard part. We want to figure out, because this equation is going to vary depending upon where these are when they, if it's accelerating or not when they collide, we want to figure out if we're still accelerating at the time when either of these collisions happen. So we're going to start with time is equal to 1.6 repeated seconds. With that, we can say tractor 1, where are you? Well, tractor 1, we're going to say x final, which is what we're trying to find, is going to be x initial plus velocity initial times time plus 1/2 acceleration times time squared. X final is what I want to know. But this is really, instead of x final, we're going to say x at t is equal to 1.6 repeated seconds. It's going to be x initial. X initial is at position 0. Velocity initial is 0 times my time, which is just going to go away. So I'm not going to worry about writing that in there. Plus 1/2. My acceleration is 1.5 meters per second squared. 1.5. And my time is 1.6 repeated seconds. And that has to be squared. So my x at time of 1.6 for tractor 1 is going to be 1/2 times 1.5 times 1.6 repeated squared. That number, I cannot do in my head, is going to be 2.083 repeated meters. So it has gone just over 2 meters by the time it is going the same speed. And at this point, it is no longer accelerating, because if it were still accelerating, it would go over 2.5 meters per second. So this is where tractor 1 hits its constant speed. Where is tractor 2 at this point? Well, tractor 2 is the same equation. X final is what we want to find, which is not x final anymore. This is x of tractor 2 at time of 1.6 repeated seconds. This is where under all my subscripts get a little bit messy because of the size of the board. I apologize. This is going to be equal to x initial. Well, x initial for the tractor 2 is at 10 meters. My velocity initial is still 0. And I've got 1/2 times -1 is my acceleration. I'm running out of board space, I apologize. Times 1.6 seconds, repeated seconds squared. So 10 plus 1/2 times all of that is going to show me that it has gone 10 minus, it's gone there's a decimal, 1.38 repeated meters. So that is, I did not write this guy down. It's going to be at a position of 8.62 repeated meters is going to be that position. This has not reached tractor 1, so that means that we have not run into each other yet. So we are set. It is no collision at 1.6. However, what I am going to do is I'm going to mark this, how do I want to call it? X of tractor 1 at 1.6 repeated seconds. It's going to go 2.083 meters before it starts going at the same speed forever and ever. Amen. So we have that. Hoofda. Small board makes this hard. Now, we want to know at time of 3.5 seconds. Have we reached, I've got to deal with that square and the fact that I'm off the top of the board. Time of 3.5 seconds. Have we collided yet? Well, tractor 1, we'll skip. Tractor 2. I'll show you why we skip tractor 1 in a second. Tractor 2, where are you? Scooby-Doo tractor, apparently. X I'm just going to do X final is equal to X initial plus V initial times t plus 1/2 at squared. X final is going to be x tractor 2 at 3.5 seconds is going to be equal to x initial. X initial is 0, oh sorry, is 10. V initial is 0 plus 1/2 a, whoops, what am I doing? -1 meters per second squared times time, which is 3.5 seconds squared. Okay, I can solve for that. That's going to be 10 minus 6.125 meters, which is going to be 3.875 meters. So tractor 2 is at a position of 3.875 meters. What about tractor 1? We can't just use this big equation because now we're going at a constant velocity. So what we're going to do, tractor 1, we know that at a time of 1.6 repeated seconds, we have a velocity of 2.5 meters per second, and we have an acceleration of 0 because we've stopped accelerating now, and we have a position of 2.083 repeated meters. So what we're going to do is we're going to do the same thing, but we're going to write x at 3.5 seconds is going to be equal to x at 1.6 repeated seconds. So instead of starting at time 0, I'm starting at 1.6 repeated, plus velocity at 1.6 repeated seconds times time. And this is the time between 3.5 and 1.6 repeated. I am very sorry. This is probably harder to read than the whiteboard, but space. Plus 1/2, my acceleration is 0 t squared. That just goes away. So I'm just going to erase it. So my position of that tractor at 3.5 is going to be equal to that 2.083 repeated plus 2.5 times the difference in time of 3.5 minus 1.6 repeated seconds. Hopefully it makes sense where that came from, because all that we're doing is saying that we're now want to know how much further it's gone, how far it is. We know where it is at 1.6 seconds. It's just like the water balloon problem where we could start from the top or start from the initial. It's just a matter of making sure that your acceleration is constant over the entire thing. So we have to do this in two pieces. We had to do the 1.6 seconds and this separately in order to make everything work. This is going to tell us that at this time, I have gone 6.6 repeated meters. I'm at 6.6 repeated meters. Well, 6 meters means that this guy has moved from here to 6 meters, and this guy has moved from here to 3.8 meters. which means they have now already gone through each other, meaning that collision has happened sometime before 3.5 seconds. So we have some work to do. Okay. I think I'm just going to erase all of this. This is a complex problem meant for you guys to have to think through a little bit. Okay, so let's think about how we can describe this picture now that we know approximately where it's going to be happening and what's going to be happening at that time. I can say that the distance between these two pieces is going to be equal to the distance that tractor 1 has traveled. Well, no. I want to write in a different order than I have in my notes. The distance here is going to be equal to the 10 meters, which is the initial, minus the distance that tractor 1 has traveled, minus the distance that tractor 2 has traveled, because they're both moving together. Okay? Well, I'm trying to solve for when this distance becomes 0. So what I'm going to do is I'm going to go back to what I just did with that previous equation and see if I can't solve for where that is. So I just said that the position of tractor 1 is going to be equal to 2.083 repeated plus that 2.5 times the time that it's been minus 1.6 repeated seconds. So that's how long after we've hit max speed it is. So all this is x at t1 is equal to x of tractor 1 at the time of collision is going to, or at any time, is going to be x of tractor 1 at 1.6, and put it at, plus my velocity at 1.6 times time minus 1.6 repeated. This is all this is again saying that x final is equal to x initial plus v initial t plus 1/2 at squared. Written that out a ton. Acceleration is 0 after it hits that point. X initial is 2.083 repeated. V initial, or V at this 1.33 seconds, is 2.5. And my time, well, I'm starting at a time of 1.66 and going to whatever time I'm after. So this is my equation for that. So that whole thing is xt1. And then I've got to subtract xt2. So it's going to be the same thing. xt2, or x final of tractor 2, I've already lost my star idea, is going to be x initial. And now I'm not actually talking, I'm talking about this as positive. So that's going to be a little bit confusing, but I'll talk about that in a second here, because I'm after how far it's traveled. Plus v initial times time plus 1/2 acceleration times time squared. Whew. Okay. Initial velocity, initial position is 10, but I want to know how far it's traveled, so I'm going to go ahead and flip this over, and how far it's traveled is going to be 0, because it hasn't moved at all at this point. So no movement yet. So this is 0. Velocity initial. Well, it's not moving to start. So at time 0, there's no movement. So there we are. So this is going to be 1/2 acceleration times time squared. I am going to say that this is 1/2 times 3.5 times time squared. Why did I do that? We've got a positive 3.5. I'm after the change in position. I'm switching everything to positive. I could say that this is going to be equal to 10 plus this, and then that's negative, and that is my change in position. But then what I want to do is I want to take that entire thing and say 10 minus this is how far I've gone, because that's what this xt2 is. Hopefully we can wrap our heads around that a little bit. So that means that this is, I wrote 3.5 here. This is 1. I grabbed the wrong acceleration. That is my fault. So this is 1/2 times 1 times t squared. I don't have to worry about the t minus 1.6 because this one is talking about from the start of time. Now all I have to do is solve for t, which unfortunately is going to mean quadratic formula. X equals the, let's write it out first. Let's write it out that this says 0 is equal to 12.083 repeated minus 2.5t minus 0.5 t squared. And hopefully that reminds you of x equals the opposite of b plus or minus square root. So we're going to go t is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Losing pen here. So with this, we have b is, okay. What I did here is I doubled a lot of this before I did it. So I called b is equal to negative, we can leave this. B is negative 2.5 plus or minus the square root of b squared, so 2.5 squared, the negative goes away because it's squared, minus 4 times a, which is 1/2, times c, which is 12.083 repeated, all divided by 2 times 1/2 is going to be what I'm after, and that comes out to t either be equal to 3.015 or negative 8.015. Hopefully it's clear which of those it is, because we don't want a negative time. So our time at the collision is 3.015 seconds. Okay. Looked really hard, is really hard. Don't worry, this is not I will not have you do any quadratic formula stuff on exams. But the main purpose of this is showing that this is not working the same way as that day one question where we had relative motion. We have to keep these things in check. Last thing we have to do is where is x1 at the time of collision? Where is tractor 1? So all we have to do for that is x1 final is going to be equal to x1 initial plus v initial times t plus 1/2 at squared. And we are doing this we're going to do this from comparing time of 1.6 repeated seconds to a time of 3.015 seconds. So what it comes out to is x1 final is going to be equal to my initial position at the 1.6 seconds is this 2.083 repeated. My velocity at this point is going to be equal to 2.5. And my time is the time between 3.015 and 1.6 repeated seconds. And then my acceleration is 0, so plus 0. And I can plug all this in and say that x1 final, the point where this collision happens, is at 5.45 meters away. There is a decimal point there. That was a long one. That's why it may not happen during class. But hopefully you can kind of see how this thought process works, how you can kind of work through, starting with a little bit more complicated problem, how to go through these relative position problems. I do not expect you'll see anything this difficult unless maybe on one of the review quizzes, which you have all the time in the world for. So take care.